Hello students, in today's lecture we will learn units and measurements, and this is theory part, NCERT section 1.1 and 1.2. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So, in today's lecture, we will cover 1.1 Introduction, 1.2 the International System of Units. So, introduction. Our main motive to understanding physical quantities, their types and units of measurements. So here question arises, what is units of measurements? So using units or measurements, we can determine the quantities, length, like length, mass and volume. It means all quantities which are used to describe laws of physics are called physical quantities. Like, for example, length, mass, volume. Physical quantities are two types. First is fundamental quantities, which are independent of other physical quantities. That's why we called fundamental quantities. Second is derived units. So here derived units means the units which is derived from fundamental units is known as derived units. Measurement of any physical quantity. Listen carefully. Measurement of any physical quantity involves comparison with a certain basic quantity, arbitrarily chosen internationally accepted reference standard and called unit. So, to represent any physical quantity, we will use the term unit. The units which are used to represent fundamental quantities are called fundamental or base units. The unit of derived quantities which are represent in terms of fundamental units are called derived units. It means there is two important things. First is base units, second is derived units. So base units are fundamental quantities which is independent of other physical quantities, whereas derived units is units which is derived from fundamental units, or we can say which is derived from base units. That's why we called derived units. So the International System of Units, NCERT section 1.2. Our main motive to understand fundamental, derived units and measurement. So we know what is fundamental units. Fundamental units are base units and derived units is which is derived from fundamental units. Some of commonly used systems of units for measurement with the base units for length. mass and time are given as in CGS system. So there is a some systems. First is CGS system. In CGS system, three quantities: length, listen carefully, length, mass and time. In CGS system, length measured in centimeter, mass measured in gram, and time measured in second respectively. So this is CGS system. Second system is FPS system. Similarly, in FPS system, length measured in foot, mass measured in pound, and time measured in second respectively. Third system is MKS system. In MKS system, length measured in meter, mass measured in kilogram, time measured in second respectively. So these are the types of systems. There is one more system, or we known as SI system, or we can say International System of Units. So here question arises, what is International System of Units? The system of units which is at present internationally accepted for measurement is known as, or is called, International System of Units, or we can say SI unit. This system contains 7 fundamental units and 2 supplementary units. We know what is fundamental units? Base units or fundamental units. So if we talk about the International System of Units, so there is a 7 fundamental units and 2 supplementary units. So let's talk about the 7 fundamental units and 2 supplementary units. So table 1.1, SI base quantities and units. So we know there is a 7 fundamental base units. So first is length, second is mass, third is time, fourth is electric current, fifth is thermodynamic temperature, sixth is amount of substance, and 7 is luminous intensity. So these are the 7 fundamental units, or we can say 7 base units which is accepted internationally. Clear? Now what is the name of these base units? First is length. Length name is measured. Length measured in meter, and symbol is m. So the meter symbol m is the SI unit of length. So what is SI unit of length? Meter. And how we can define it? So it is defined by taking the fixed numerical value of speed of light in vacuum, C, to be this quantity when expressed in the units of meter per second. So meter per second is the unit of speed, where second is defined in terms of Caesium frequency. So this is our first fundamental unit. Second is mass. Mass measured in kilogram, and the unit of kilogram is kg. So all these 7 units are internationally accepted. That's why we called international system of units, or we can say SI system. So kilogram symbol is kg. SI unit of mass is kg, and it is defined by taking the fixed numerical value of Planck's constant. Here h is to Planck constant, to this one. The value of Planck constant is 6.62607015 into 10 raised to the power minus 34. This one. This is the numerical value of Planck constant. When expressed in unit joule second, which is equal to another unit, and that is kg meter square per second, where the meter and second are defined in terms of C and this one. So mass is a second base unit or second fundamental units. This is clear. Our third unit is time. Time measured in seconds, and symbol is S. Second is SI system of SI unit of time. It is defined by taking the fixed numerical value of the calcium frequency. The unperturbed ground state hyperfine transition frequency of the calcium 133 atom. So about this concept you will be learn in upcoming lectures. So our main thing here is time measured in second. Third is electric current. Electric current, and electric current is measured in ampere, and unit is A. A means ampere. The ampere symbol A is the SI unit of electric current. It is defined by the taking fixed numerical value of elementary charge. This one. E is the elementary charge, and 1 E, or we can say 1 electron, is equal to what? 1.602176634 into 10 raised to your minus 19. So this is the charge on electron, 1.6 into 10 raised to the power minus 19 coulomb. When expressed in the unit C, C is the unit of charge, that is coulomb, which is equal to A, ampere second, where second is defined in terms of this one. So this is the fourth base quantity, and fifth is thermodynamic temperature. Thermodynamic temperature, name is Kelvin, measured in Kelvin, and symbol is K. K is the symbol. Clear? So Kelvin having symbol K in SI system, and or we can say this is thermodynamic measured in thermodynamic temperature, and defined by taking the fixed numerical value of Boltzmann constant K to be this one, when expressed in unit joule per Kelvin. Which is equal to kg meter per second square per Kelvin, where the kilogram, meter and second are defined in terms of HC and this one. Clear? And sixth base unit is amount of substance. amount of substance, and measured in mole. The 1 mole is equal to this one. 1 mole is equal to this one. 6.022 into 10 raised to the power 23. This is 1 mole. And symbol is MOL. MOL. Now, mole is the unit in SI system, or we can say amount of substance. Amount of substance. 1 mole contains exactly this one elementary entities. The number is 6.022 into 10 raised to the power 23. This number is the fixed numerical value, or we can say Avogadro constant Na. So Na is what? Na is the Avogadro constant when expressed in the unit per mole, and called Avogadro number, or we can say Avogadro hypothesis. The amount of substance, symbol this one, N, or we can say mole, of a system is a measure of number of specified elementary entities. And elementary entities may be an atom, a molecule, an ion, an electron, and other particle or specified group of particles. It means if we talk about the mole, so 1 mole is equal to 6.022 into 10 raised to the power 23 elementary quantities. And if we talk about the charge, it means 1 electron is equal to 1.6 into 10 raised to the power minus 19 coulomb. And if we talk about the Planck constant, so it will be 6.6 into 10 raised to the power minus 34. And if we talk about the speed of light in vacuum, so it will be 3 into 10 raised to the power 8 meter per second. So these are the base units, their name and symbols. 7 is luminous intensity. Luminous intensity. The name is candela and symbol is CD. CD means luminous intensity. It is the SI unit of luminous intensity. Now, candela, symbol CD, is the SI unit of luminous intensity in given direction. It is defined by taking the fixed numerical value of the luminous efficiency of monochromatic radiation frequency, this one, and where frequency is 540 into 10 raised to the power 20 hertz. So these are the 7 base units, or we can say fundamental units in SI system. Clear? Now if you have any doubt, please ask. Related to SI base quantities and units, if you have any doubt, please ask. There is a 7 base units: length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So luminous intensity, okay, luminous intensity, the base unit, it is a base quantity and name is candela and symbol is CD. So suppose you when we switched switched on the torch, switched on the torch, so the light of the torch cover a specific area in a given direction. Listen carefully. When we switched on the torch, so the light of the torch cover specific area in a given direction. Yes or no? In a given direction. If we on the switched torch, light cover a specific area in a given direction. So that area are measured using the concept of luminous intensity. Avogadro means it specify the number 6.1. The Avogadro number is this one, 6.022 into 10 raised to the power 23 elementary entities. It means 1 mole is equal to 6.022 into 10 raised to the power 23 elementaries. About more about the uh, Avogadro number you will be learn in upcoming lecture. Clear? So let's move further. Uh, so derived quantity means the quantities which is derived from base units. There is a 7 base units. Yes or no? Length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So the quantities which is derived from these base units are known as derived quantities. More about the derived quantities we will learn in upcoming lecture. Suppose one example. Suppose velocity. Suppose we have a velocity. So velocity is what? How we can find velocity? The unit is meter per second. Meter per second. Velocity is meter per second. It means what? Distance upon time. Yes. So here meter and second is the base units. Meter and second is the base unit. Look at here. Meter means it specify the length, and second it specify the time. So length and time is the what? Is the base quantities, and from these base quantities we can define a new term, that is here meter per second. So velocity is equal to meter per second. Clear? So some units retained for general use. So first is though outside SI. So like minute, hour, day, year. Similarly, degree, liter, ton. This one is ton. Carat, bar, curie. So similarly, all these. So minute symbol is MIN. It means minute. And value in SI system is 60 second. 1 minute is equal to 60 second. In SI system, for the time, the unit is second. So that's why 1 minute is equal to 60 second. Second is hour. So symbol is H. It means if we talk about the hour, or we can say H, so it will be we need to convert it in second, because in SI system the symbol the unit is second of the unit of time is second. That's why 60 minute is equal to 3600 second. 1 minute 60 second and 60 minute 3600 second. 60 into 60, so you will be get 3600 second. Third is day. Day denoted by symbol is D. So 1 day means 24 hour. 24 hour. And in 24 hour, how much seconds? 86,400 seconds. Similarly, year. Year is denoted by Y. Y means year. 1 year is 365.25 day. It means in second, if we talk about in second, so it will be 3.156 into 10 raised to the power 7 seconds. Look at here. Minute, 1 minute 60 second. Similarly, hour, day, year. Next is degree. And degree is represented by this symbol. Look at figure. 1 degree is equal to pi divided by 180 radian. And liter. Next is liter. 1 liter is equal to this one, 10 raised to the power minus 3 meter cube. Ton. Ton denoted by T. And value in SI unit is 10 raised to the power 3 kg. Carat unit is C. And value in 200 mg. 1 carat equal to 200 mg. Bar 0.1 megapascal is equal to 10 raised to the power 5 pascal. So this is the unit of pressure. Bar is the unit of pressure. Curie denoted by this symbol Ci. And value in SI system is 3.7 into 10 raised to the power 10 per second. Similarly, this one. So this one is Roentgen. Symbol is R. So value in SI system is 2.58 into 10 raised to the power minus 4. Unit is this one. Quintal denoted by symbol Q. In 1 quintal 100 kg. Barn denoted by B. 1 barn is equal to 100 Fermi meter square, or in meter it will be 10 raised to the power minus 28 meter square. and this one is R, symbol is A, and it is 1, value in SI system is 10 raised to the power 2 meter square. Similarly, hectare, 1 hectare is 10 raised to the power 4 meter square, and standard atmospheric pressure. Standard atmospheric pressure is ATM. So the value is this one, 1.013 into 10 raised to the power 5 Pascal. It means 1 ATM is equal to 1.013 into 10 raised to the power 5 Pascal. Clear? These are the some units regained for general use. If you have any doubt, please ask. ATM is the ATM. Look at here. ATM, standard atmospheric pressure, or 1 ATM is equal to, if we talk about ATM in terms of Pascal, it will be 10 raised to the power 5 Pascal. 1 ATM is equal to 1.013 into 10 raised to the power 5 Pascal. And Curie is this one, 3.7 into 10 raised to the power 10 per second. This one, barn, 1 barn is equal to this one, 100 Fermi meter square is equal to 10 raised to the power minus 28 meter square. Pascal is a unit of pressure. Now it is clear. Degree is we will use degree for measuring angle. 1 degree means, look at here, 1 degree is equal to pi divided by 180 radian. Suppose you have a 2 degree, we can say 90 degree. 90 degree. So 90 degree is equal to how much radian? So to convert degree to radian, the formula is this one. 1 degree is equal to pi divided by 180 radian. So now to convert 90 degree in radian, so just multiply 90 into pi divided by 90 pi divided by 180. So you will be get in radian. Yes, half radian. Any doubt? So next is supplementary units. This is the also part of international system of units. Look at here, in figure A, shows plane angle and figure B solid angle. So plane angle is denoted by theta and solid angle denoted by omega. So if we talk about the plane angle, as shown in figure A, look at here. It is a two-dimensional. So like circular motion. Suppose like a circular motion in circular shape. So initial position is suppose here and final position is here. So the arc is ds and radius r. So angle covered is d theta. So d theta is equal to ds upon r. ds upon r. So it is measured in radian. Second is d omega. D omega is equal to dA divided by r square. So this is a solid angle. If we talk about the cone, so this one. So this is a solid angle. So it is denoted by d omega, or we can say steradian. It is a unit of solid angle. Steradian is unit of solid angle. So we have our two units, plane angle and solid angle. So supplement, we call it supplementary units. Radian, unit is radian if we talk about plane angle, and if we talk about the steradian, unit is steradian. And symbol of radian is rad, radian, and steradian is sr. Clear? The important thing here is this, both are dimensionless. Both are dimensionless. If you have any doubt, please ask related to supplementary units. If you have any doubt, please ask. Yes, look at here. This one is dimensionless. It means ds is equal to this one. Or we talk about d theta is equal to ds upon r. What is the unit of ds? What is the unit of arc? Tell me, what is the unit of arc? If we have a one arc like this, how we can measure? Meter, clear? And what is the unit of radius? What is the unit of radius? What is the unit of radius? Meter. So meter cancel out. Yes or no? Yes. So it means it become dimensionless quantity. Dimensionless quantity. If you have any doubt, please ask related to this supplementary units. Example on solid angle we will solve in upcoming lecture. So here in previous slide we already learned 1 degree is equal to pi divided by 1 by 80 radian. Yes or no? One degree is equal to pi divided by 180 radian. So this is useful to convert degree to radian. Clear? Any doubt? So there is a 7 base unit, or we can say 7 fundamental units and 2 supplementary units, and that is plane angle and solid angle. For the visualization, you think about a cone ice cream, and last part, suppose this solid angle. Yes, think about a watermelon cut into a piece. So the angle, the this type of angle here, look at here, d omega is a measured in steradian. Any doubt? So next is least count. So least count is a useful, or we can say uh, it is a measuring instrument. Least count of a measuring instrument is the smallest value that can be measured or resolved by that instrument. It's a measure of instrument's precision and accuracy. It means least count tell us about the precision and accuracy of the experimental data. A smaller least count indicates higher precision. Smaller least count, higher precision, meaning the instrument can measure smaller changes in a quantity more accurately. Next is least count error. The least count error is the error associated with the resolution of the instrument. It occurs with both random and systematic errors. So there is a two types of errors: random errors and systematic errors. Random error occurs randomly, and systematic errors occur due to the instrument, due to the experimental instruments. Clear? The smaller the least count, listen carefully. The smaller the least count, greater is the precision for a measuring instrument. It means the value of least count is small, the precision is high. More about least count and least count error we will learn in next lecture. Any doubt? Any doubt related to system of units or least count and least count error? Precision means, precision refers to the consistency or repeatability of measurements. Suppose a student measure a length of a uh, suppose a student measure length of a road 3 times and records the value as, suppose we have 15.24, 15.25 and 15.23. It means there is a three values and they are close, very close to each other, and another student find the value 15.25 and 15.24 and 15.22. So this is a very close to each other. So difference is what? If we talk about the precision, so there is a very negligible difference. And if we talk about the accuracy, so it indicates how close a measurement is to the actual value or true value from the experimental data and theoretical data. Now it is clear? Clear? Now here one question for you. What is the unit of velocity? What is the unit of velocity? What is the unit of velocity? Second question. What is the unit of acceleration? What is the unit of acceleration? Yes. So using the base units, we can derive another units or called derived units. Meter per second square. Now if we talk about the force, or we can say, if we talk about the, yes, Newton. One more question. What is the unit of current? What is the unit of current? Now, if you have any doubt, please ask. Good. Related to base unit, related to derived units, related to SI International System of Units, least count, and least count error. Base units, or the name suggests base. Base means fundamental. Fundamental units are known as base units. There are 7 types of base units. And use of radian is used for measuring angles. Least count error. Thank you for your attention.